Welcome to the viewers. Now we discuss the addition of vertices and edges to a graph. At first, we consider here the addition of vertices. Discussion of addition of vertices. Addition of a vertex to a graph. At first, let us consider G be the graph and V dash be the vertex of. Suppose if we consider here V dash be the vertex of G, then G union V dash is the new graph which is added to G. If we considering a figure, it will be better to understand. Suppose V1 dash, V2 dash, V3 dash, V4 dash, and V5 dash, V4 dash. Here it is V4 dash and V5 dash. And if they are connecting with the edge, E1 dash, if it is E2 dash, if it is E3 dash, if it is E4 dash, and if all of these are connected with the edges, E5 dash, if it is E6 dash and E7 dash, and if it is considered as a graph G, and now if we add it with this graph with another extra vertex V1 V2, like a V2, and V3 V4, and here it is V5, so it is V1 dash, and here it is V2 dash, here it is V3 dash, V4 dash, and V5 dash, connected with the edges like E1 dash, here it is E2 dash, if here it is E3 dash, if we consider here it is E4 dash, and here we consider this E5 dash, and now if it is E6 dash and E7 dash, then if we added extra vertex like V dash 6, then the new graph will be this union V dash 6. This is a new vertex. So in this way we can find the addition of vertex to a graph. Now we consider addition of edge to a graph. So here is the same things. At first, if we consider the definitions, how to, this is a simple things. Addition of an edge to a graph. If G be a graph and considering any two vertices u v shape, as we consider, we added, suppose u dash v dash, we added a new edge e dash belongs to eg, that's joining u dash v dash, then the resulting subgraph is G union E dash is a graph whose vertex set is V dash G and edge set is E dash G union E dash. And in the earlier problem, in the earlier cases, addition of the graph, here extra point is to be added, the new graph which is a subgraph actually of vertex set. So here this is a subgraph of vertex set Vg union V dash, V dash G union V dash, and edge set E dash G. Here it is V dash G union V dash. Addition of these two. And in this way we can say the definitions and few of the definitions of ideas, how to add and how to delete with vertex and edge. And now here we consider that another figure like this. V1 dash, V2 dash, V3 dash, V4 dash, V5 dash connected with E1 dash, E2 dash, E3 dash, E4 dash and E5 dash. If we consider as a graph G, it's connected with V1 dash, V2 dash, V3 dash, V4 dash, V5 dash and V6 dash, E1 dash, edges, E2 dash, E3 dash, E4 dash and E5 dash. This is a graph. If we add with the edge V1 dash, V2 dash, V3 dash, V4 dash and V5 dash connected with edges E1 dash, E2 dash, E3 dash, E4 dash and E5 dash. If we add one more edges like this E6 dash, then the new graph will be G union E6 dash. So in this way we can join the edges. Now we consider the isomorphism of a graph. Isomorphism of graphs. When two graph, if we consider two graphs G1, G2 are called isomorphic if there exists a 1-1 map if we consider G from V dash G1 to V dash G2 and also 1-1 map psi such that E dash G1 to E dash E dash G2 such that for every edges E dash belongs to E dash G with endpoints say U dash V dash in V dash G. The map F actually the function F maps U dash and V dash to the end point of psi of E dash in V dash G2. That is, we preserve incidence relation here. At first, let us understand what happens there. Two graph will be considered here and we know already, and there is a map, it is a 1-1 map, and also another map we consider, it is a vertex and edges, and there are the end points. For every E dash belongs to EG dash, here it will be every belongs to EG1 dash actually, G1 dash with endpoints U dash V dash in V dash G1 here. Actually, the function of U dash V dash to the endpoint of psi, another mapping EG dash, psi of E dash in VG dash 2. Here we find the map. That's a 1-1 correspondence, nothing but 1-1 correspondence we find. It is the main object of isomorphism of graphs. That's the same case in the group theory also, in abstract algebra. It's applied in the sense in the cases of the graph theory. And we know also in the abstract algebra what isomorphism is. We get some concept, but here it is like the quite same, but we apply it through the vertices and edges. Some differences is there, but the same thing. We consider here also the map and consider here vertex, two maps here, vertices and edges, and here here is a 1-1 correspondence. We consider here edges, and that's connected with one vertices, and the result of the function we get another endpoint of edge vertices in another connected vertices. Like as a function, there is a map from 1 correspondency we find in this way. Now with the help of example, it will be clear more easier. If we consider a given figure of two graphs, here if we consider two graphs u1 dash, u2 dash, u3 dash, u4 dash, u5 dash, connected with edges e1 dash, e2 dash, e3 dash, e4 dash, e5 dash, e6 dash, and if we consider here is a loop e7 dash. And now if we consider here, that's corresponding u dash v dash, we are getting maps to the two endpoints. So here u dash is transposed to v dash. So if we consider here v1 dash and two graphs like this, v2 dash, v3 dash, v4 dash, v5 dash, connected with u1 dash, and it is e2 dash. If we adding these two with the edges, that is e6 dash, corresponding 1 to 5, and here it is v4 to v5 and u4 to u5 corresponding, that is u4 dash and u5 dash, that is e5 dash. So it will be e dash 4, and another v3 v4 dash. So u3 u4 dash we consider u3 dash and u4 dash, that is e3 dash. So it will be taking at better double dash, because here it will be dash, so it will be double dash, e3 double dash. And if we consider here another like u2 dash and u5 dash, u2 dash and u5 dash, that is e5 double dash. So in this way we consider here another extra mode added, that is a loop, it will be e7 double dash. So here if we define G, a map from v dash g1 to, if we consider the graph taking it as g1 and it is taking it as g2, then v dash of g1 to v dash of g2, it is a map by g of, we consider here ui dash, that's mapped to vi dash for I runs from 1 to up to 5. For I equals to 1, g of u1 dash, that is v1 dash, u1 dash, that is v1 dash, here we consider. So in this way we find it is a vertex concept. So finally we consider here the map. So definition criteria is satisfied. Next, edges concept, that is a psi. here you consider one map psi from E dash G1 to E dash G2. So in this way, psi from edge of E dash G1 to G1 to G dash 1 to here it is also E of E dash of G2 by psi of E dash J, that will be E double dash J. J runs from 1 to up to 7, and we already know that psi of that is E dash 1, and it will be E double dash 1 E double dash 1, that is connected. So we see here from these two functions, we see G and psi are 1 map such that the incidence relation is preserved. Hence, both G1 and G2 are isomorphic. So in this way you can say which two maps are isomorphic or not with the help of a given figure, and some of the criteria that I discussed already from the definition. Now if we like this video, we end our class, and if you like this video, like it, share it and subscribe the channel. Thanks for watching.